Hello everyone, this is the Theoretical Doctor and welcome to my first ever video on this channel. If you want to access flashcards on this topic and other videos, do click the link below. I post weekly videos every Tuesdays and Fridays, so do subscribe for more content. So let's start off with the chemical properties of water. Here's the structure of the water molecule. So as you can see here, there is one oxygen atom and two hydrogen atoms. So they are actually arranged at an angle of 104.5 degrees. So take note that the hydrogen atoms are actually linked to the oxygen atom through covalent bonds. Okay, so it's important to note that water is actually a dipolar molecule. This is because oxygen is slightly negative and hydrogen is slightly positive. That's why they're able to actually bond with one another. But do remember that the bond over here is covalent bond and they're arranged at an angle of 104.5 degrees. How are the water molecules linked? In the previous slide, I mentioned that this is how it's arranged, right? But this is just for one water molecule. So if you have a few, how are they actually linked? So they are linked by weak hydrogen bonds. So the weak hydrogen bonds are actually electrostatic attraction between the positively charged hydrogen atom and the negatively charged oxygen atom. So if you see this picture, this is one water molecule and this is another water molecule. So take note of the hydrogen atom over here and the oxygen atom over here. So they are linked by the weak hydrogen bond. Next is the state of water. So I mean, like most of us, we consume water on a daily basis, right? Like we can't live without it. Anyway, water is liquid at room temperature. Well, we all know that. So at freezing point, water turns into solid, and at boiling point, water turns into gas. So the thing is that one water molecule, let's look at the middle one over here, they are able to form a maximum of 4 hydrogen bonds with different molecules of water. So take note, I mentioned different molecules of water, okay? So this is one molecule, this is one molecule, this is one molecule, this is one molecule. So focus on the center one. So you see there's one linked to another water molecule, there's one linked to another water molecule, there's one linked to another water molecule, and this is the fourth one linked to another water molecule. So the thing is that they're able to form a maximum of 4 hydrogen bonds. The thing is that when it's in liquid state, they do form 4, but sometimes it's not 4, it's less, or maybe 3 or 2. It's uneven and they're constantly forming and breaking and forming and breaking. But then as the temperature lowers, meaning you're going to reach freezing point somewhere around there, so the thing is that when the temperature lowers, there are actually more hydrogen bonds being formed. At the point where it's freezing point, all molecules will be involved in the hydrogen bonds. So therefore, you will actually get a hexagonal lattice structure. So if you actually look over here, if you connect the edge, you know, all the hydrogen bonds over here, you get 1, 2, 3, 4, 5, 6. So you actually get a hexagon 6. So this is how it looks like. Okay, so a little bit on water as a universal solvent. Now the thing is that, you know, as I mentioned earlier, water is actually you have one oxygen atom, 2 hydrogen atoms, and hydrogen is slightly positive, oxygen is slightly negative. So you have positive and negative, and the thing is that the polarity of that water makes it a suitable solvent for ions, polar molecules to actually react with water. So they allow chemical reactions to occur. So now if the substance actually dissolves in water, then that substance is actually called hydrophilic, means it loves water. Philic is love. And if the substance doesn't dissolve in water, like it just can't form any chemical reaction, it's hydrophobic. Phobic, it hates it, like you have phobia. So polar substances are actually hydrophilic and non-polar substances are actually hydrophobic. Okay, so just a summary on the chemical properties of water. Water contains 2 hydrogen atoms and 1 oxygen atom in a bent molecule of 104.5 bond angle. Okay, so just refer back to the picture earlier. And water molecules exhibit polarity and they form hydrogen bonds with one another. So remember that when the hydrogen atoms connect to the oxygen atom, it's covalent bond. But when one water molecule connects to another water molecule, they form hydrogen bonds, weak hydrogen bonds. And also another fact is that water is chemically inert and it's a good solvent for reactions and transport. Alright, so let's move on to the physical properties of water. Alright, so the first one, water has high specific heat capacity. So a definition over here. Water has high specific heat capacity of 4.2 kilojoules per Kelvin per kilogram. So I know that's like a mouthful, but essentially it means that 4.2 kilojoules of heat is required to raise the temperature by 1 Kelvin for 1 kilogram of water. So to put it into summary, you need 4.2 kilojoules of heat to actually raise the temperature by 1 Kelvin. And what it means actually is that a lot of energy, a lot of heat energy is required to raise the temperature of the water. And why you need a lot of energy? It's because you need to break the hydrogen bonds within the water molecule. So as I mentioned earlier, how one water molecule connects to another, it's through the hydrogen bonds. So you need to break that hydrogen bond. So the amount of energy required is 4.2 to raise 1 Kelvin. So yeah, temperature is raised when the individual molecules or atoms vibrate vigorously. So why is this important actually? You see, the thing is that in the sea we have other organisms living there, right? You have the fishes and other aquatic organisms. So the thing is that if water doesn't have a high specific heat capacity, by now the water would have evaporated, the animals would have died. And the next one is high latent heat of vaporization of water. So water has a high latent heat of vaporization of 2260 kilojoules per kilogram, which means that 2260 kilojoules of heat is required to vaporize. So earlier, it's about raising the temperature. Take note that specific heat capacity is about raising the temperature, and latent heat of vaporization is to vaporize, meaning to turn liquid into gas. So essentially it means that a lot of heat is required to change water to vapor. Why? Because it requires the breaking of all the hydrogen bonds. So you need to break all of it, then only it can vaporize. If it's still linked, you still have liquid state. So vaporization always results in the cooling of the surroundings, and you have that through evaporation or boiling. Now, a little bit of recap here. Evaporation occurs on the surface and it provides the maximum cooling effect with minimum loss of water, but whereas for boiling, it occurs under the surface of water at the boiling point of water. Now, how is this important? During sweating, water acts as a thermal buffer whereby it absorbs heat in our body and evaporates, providing a cooling effect, enabling enzymes to function optimally and prevent denaturation of biological molecules. Water evaporating during transpiration in plants lowers the temperature of the leaves and cuts down overheating when exposed to sunlight during photosynthesis. So basically, when we sweat, the water will evaporate, so it will absorb the heat in our body and it will evaporate and it will bring a cooling effect. And also during transpiration is when water evaporates from the surface of the leaves. How is it important? Is actually the water prevents heat from directly affecting the leaves or the plant. so it acts basically like a defense mechanism. Okay, so next is the density of water. So it's important to note that density or specific gravity of water is highest at 4 degrees Celsius. It's very important to remember this, highest at 4 degrees Celsius. So when water is cooled to 4 degrees Celsius, it sinks. This is because at 4 degrees Celsius, water molecules are most compact with the shortest intermolecular bonds. Further cooling will cause it to float. So, if you have a cold drink with some ice in it, the ice will float, right? Now, that occurs after 4 degrees Celsius. So, at 4 degrees Celsius, water is cooled, it sinks. Now, at freezing point, at 0 degrees Celsius, water freezes. Yeah, we all know that water freezes at 0 degrees Celsius. What happens here is that ice expands during freezing as hydrogen bonds occupy more space. So remember in one of the slides I mentioned that at freezing point, that is when the maximum amount of hydrogen bonds per water molecule occurs. So now imagine when it's at freezing point, there are so many hydrogen bonds being formed, and for that it occupies a lot of space. So that's why ice expands. So when ice expands, actually it results in lower density, and that's why it floats. Now, take note of this. Freezing starts from the top of the water surface and moves downwards as the surface is subjected to low temperature first. I mean, yeah, it's on top, right? So it is being subjected to low temperature first, so that's why the freezing starts on top. But the thing is that after it has reached a certain thickness, so now imagine that there's a lake, and the top layer of the lake is actually undergoing freezing, and it's really thin, like they're thin ice, you can't walk on it, it's dangerous. Now freezing starts at that part, and it will continue to go further below. But after a certain thickness, the whole lake doesn't actually freeze up like if you put the ice cream in the fridge and the whole thing freezes up. No, it doesn't actually become like that. It actually freezes to a certain thickness, and what happens is the water that is below that thickness doesn't actually freezes. What happens is when a certain thickness is formed, ice insulates the water below. Why? Because heat is unable to escape. And if heat is unable to escape, it actually prevents further freezing, basically just circulating underneath the ice. So this is important because in countries, sadly, Malaysia, we don't have snow, but that's okay. Anyway, so in countries where water freezes, there's snow and everything, the whole lake or river doesn't actually freeze up. So the animals and the fishes, the aquatic organisms living inside, they do not freeze to death. I mean, like they're still living, and it's because of this. So the nutrients are able to actually circulate, and life goes on basically. And then after that, when the lake melts, they will actually be able to move up, they won't die. So next is the high cohesive force of water. So water has high cohesive force. So cohesive equals attraction. Cohesive equals attractive force. So this exists among the water molecules due to the hydrogen bonds. So imagine like there are two people. There's a long string, right? Okay, and then one person holds the other end of the string and one person holds the other end of the string. So now if the other person pulls the string, the other person gets pulled along. So that's actually the cohesion they're talking about. So if you see here, here's a cute plant. What happens is that because of the cohesion and adhesion, there is a transpirational pull. So water will actually travel through the xylem vessels from the roots, and it will go up to the leaves and evaporate. So what happens here is like it's not just like one droplet traveling all the way up, right? Like it's a continuous pull. They call it the transpirational pull. So what happens is when water evaporates over here, the water over here moves up and basically pulls the water molecules below to come up. So that's the transpirational pool, and that is because of the high cohesive force of water. And the last one is high surface tension of water. Now, high surface tension means that there is a strong inward pull of water forming a skin-like layer at the surface of the water, acting like an elastic membrane. Now, let's say you go to the pool, or not even, you don't have to go to the pool. You can just like fill a tub of water and just let it come down, don't let it ripple or anything. And you just look at it like it feels as if you put your palm on top of it, it won't sink, but because our palms are rather heavy, you can actually push through. But I mean, like when you actually just touch the surface, it looks like like there's a membrane over there, like there's a skin over there. So this elastic membrane is actually caused by the high cohesive force. So remember, the high cohesive force is the high attractive force. It's because of the hydrogen bonds. Okay, so it's caused by the high cohesive force, and basically surface tension is a measure of how difficult it is to stretch or break the surface of the liquid. Now, why is it important? Is because it actually creates a habitat on the water surface. Like, insects, they're not too heavy. Like in Malaysia, we're actually familiar with dengue cases. That's why they say do not store water. Like you need to close it, or you need to throw away stored water. It's not good because you may breed, dengue larvae. So this high surface tension actually enables like female mosquitoes to stand on the water and lay eggs. They don't actually sink. So after the eggs hatch, the larvae attaches to the surface and their siphons can breathe in air. Alright, so here's a summary of the physical properties of water. There are actually 5. I call it the 5H. So first, water has high specific heat capacity, and it's important to prevent quick change in temperature. Why? Because a lot of heat is required to raise the temperature by 1 Kelvin. Next, water has high latent heat of vaporization to lower temperature during transpiration or sweating, meaning that a lot of heat is required to vaporize the water, to change water from liquid to gaseous state. Water's highest density is at 4 degrees Celsius, all right? So after 4 degrees Celsius, water will actually float, it freezes. At 4 degrees Celsius, it moves below. Okay, and it's important for the aquatic organisms in places where the lakes or the rivers actually freezes. Now, water has high cohesive force. It's important for the transpiration. So remember, cohesion equals attraction, and also high surface tension. We're talking about the water surface. So it's important for the insects to carry out their activities on the surface. And now, just some biologically important functions of water that may be important for you to know for exam. So water can act as a medium for diffusion, because substances are able to diffuse across the membrane, for example the alveolus in the lung. Water also acts as a transport medium, like the blood plasma in our body, the blood circulation system actually. It transports food, gases, hormones, salt, antibodies, and waste, and it also helps in osmoregulation of body fluids. Osmoregulation of body fluids means the regulation of the ions and everything. Support. So for earthworm, because they don't actually have skeleton, they have hydroskeleton, so it's important support for them. And also for herbaceous plants, basically plants which doesn't have cell wall, these turgid cells is actually what gives support. And the aqueous and vitreous humor, they consist mainly of fluid of water. They give shape and support to the eyeball. So imagine like if your eyeball isn't like a ball anymore. Amniotic fluid is actually that fluid that surrounds the fetus, surrounds the baby when the mother is pregnant. So it's important because it protects the fetus in the amniotic sac. So yeah. And also they also act as lubricants and secretions like the mucus in our alimentary canal, our digestive system. Synovial fluids in joints, so like in our knees we actually have like a sac of fluid over there. And then yeah, it's also needed to form digestive juices for our digestion, lacrimal fluid for tears, sweat, and nectar. It also acts as a habitat because it provides an aquatic environment and support to the aquatic organisms, because yeah, we also have animals living in the sea, rivers. It also acts as a temperature control, so the evaporation of water, the evaporation of sweat will actually be able to cool off the body. And lastly is the transpiration. So transpiration, it creates tension to pull water and dissolve salts from the roots to the aerial parts. Now aerial parts are actually the leaves. So yeah, if you've reached this point, thank you very much. This is my very first video on this channel. I know I have a lot to improve. Do have patience with me, and also do subscribe and share this video to those who might find this helpful. Thank you so much, and I will see you in the next video. Bye.